Okay, for this problem, we are going to find, we're going to be working with finding the standard deviation of a random variable. So, to find the standard deviation of the random variable, we also have to find the mean of the random variable. Okay, and the mean of the random variable in this case is, since it's a population mean, we're going to be looking at mu. So to find mu, we're going to find the sum of the x's times the probability of the random variable, which is the probability of big X equaling little x. And then to find the standard deviation, we're going to go a little further. And the standard deviation of, and what I mean to say is the standard deviation of the random variable, okay? And sometimes that has a lowercase rv down there. Sometimes it'll look like standard deviation and then have an rv down here, standard deviation of the random variable, okay? It's going to be the square root of the quantity of everything, right? Of everything in here. And what's in here is the sum of the x's squared times the random variable, the probability of the random variable, which is the probability of x, big X equaling little x. It's going to be that whole sum minus mu squared. So minus the sample population, the population mean of the random variable squared. So I guess we could put down here is this is mu sub rv, okay? Just like that's sigma sub rv. It's mu sub rv. It doesn't quite look, that looks like an N rv. Okay. So there's some things we need. We need the probability of the random variable, which we just did on the other thing, right? But in this case, they're going to give it to you, right? They just give you the probability of each random variable, of 8 of them coming up, or of 7 of them, 6 of them, 5 of them, 4 of them, 3 of them, 2 of them. It gave it to you. Yay, you don't have to do all that work, right? But what we do have to find is obviously the sum of the x times the probability of the random variable. So I'm going to have to take this times this, right? Which gives me, so 2 times 0.042 is going to give me 0.084. And then 3 times 0.010 is going to give me 0.03. And 4 times 0.021 is going to give me 0.084. That's not a 1, let's make sure it's a 0. And then 5 times 0.375 is going to give me 1.875. And then 6 times 0.188 is going to give me 1.128. And 7 times 0.344 is going to give me 2.408. And then 8 times 0.021 is going to give me 0.168. So that's giving me the x times the p of x Okay? And now I can just add that all up. And if I add it all up, that's going to give me the sum of x times the random variable. So it gives me a total of 5.777 or 5.78 if we round it off to two places. Okay? All right. So we have this. Okay? And now, but what I suggest plugging in to this formula is going to be this. Get your raw. Whatever your raw number is, use that raw number. Don't use your rounded number. Use your raw number. Whatever your raw number is, use it when you plug it in to your new formula. Okay? So to get this next formula, we have to find x squares. Okay? So to find x squares, well, we got to square x.
Please say a command.
So 2 squared.
Please say a command.
2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. So, you know, and whatever the numbers are, if you had 2, 4, 7, and 8, right, you're still going to do the same thing. It's just square them, square your x's, okay? Now you have your x squares. But now you got to take your x squares, and this is the tricky part. Now you take your x squares and you times them by this, by your random probability. And that gives you your x squared times the random probability factor. So we're going to do that in green. Okay? And so when we take 4 times 0.042, this times this, we get 0.168. Look familiar? Oh, that was a point. Okay? When we take 9 times 0.010, then we get 0.09. Okay? When we take 16 times 0.021, we get 0.33, sorry about that, 336. Okay? And again, 25 times 0.375, we get 9.375. Okay? 36 times 0.188 gives us 6.768. 49 times 0.344 gives us 16.856. And 64 times 0.021 gives us 1.344. And now we just need to find the sum of this, right? When we find the sum, we get 34.937. Okay? So now we got to find the standard deviation of RV, or the random variable standard deviation, which is the square root of the sum of the x's squared times the random variable, or the probability of the random variable, which is, we'll draw that in with our green number, 34.937 minus our mu, or the population mean, the random variable population mean, which is in brown up there, 5.777, our raw value, but it's that number squared, okay? And so now we find that number and we square it. So this minus this squared is, I don't have the squared value with me, but I do have that these two subtracted gives me the square root of 1.563271. Okay, and so now I take the square root of that number, and I get the random variable standard deviation is equal to 1.25. Okay? And that's how you would do that problem. And if anything changes for the test, if you have different x's, then you just have different x's and you do the same thing. Square your x's. If you have different random probabilities, that's fine. You're just taking your x's, multiplying them by your random probabilities, and then finding that sum. That is your mu. That's your mean, okay, of your random variable mean. And then when you talk about your random variable standard deviation, you take these x's, square them, multiply by the random probability, random variable probability, and that gives you this line. Then you add all these up, and that gives you that sum that goes inside here, and you subtract it by the mu squared, and then you take the square root. Don't forget the square root, and bam, you'll end up with your answer. Okay?
You don't want to use that 5.78 instead of 577.
No, always use your raw number. Whatever your raw number is, if you can. If you can. That's why a stacking function on your HP calculators are helpful. But and some of your newer Texas Instruments will do the stacking function so that you can hold that number, right? But if it comes down to it, you use what you got. Okay? If you can't save that number, save a number, relatively, 4 digits can get the job done pretty well.